Welcome back to my channel. So, hope you are enjoying the Python skill series so far and all the machine learning videos as well as the deep learning videos which I have put in my YouTube channel. So, today what we'll be doing is as a follow-up to the previous session, that is, we did a customer segmentation data analysis using the k-means clustering. So in today's video, what we'll be doing is we'll be doing a data analysis purpose, that is a EDA activity, exploratory data analysis on the COVID dataset. So now it's a global pandemic now. So since it's started in the month of March and it's already October and we have so many data sets or data that is available. So there would be many different factors and many different key performance indicators that is called as the KPIs, which influence the prediction of what it could be or what the state of each of the countries would be tomorrow. So that insight can lead to different decision making and different strategies. So essentially what we would be doing is we would be using all of the things, that is a data summarization and the analysis and all our things that we have learned so far for analyzing the COVID dataset. So for this, I would like you to introduce a website that is called as our world in data.org. So this what you currently see on the screen is their website. So they maintain all the statistical and other information related to the recent global pandemic that is going on across different parts of the world. So that includes different states and regions, and they have many different columns which are parameters which are collected from across the hospitals on these different countries. So there are some researchers who are contributing to this. So whenever you use this data set, don't just forget to cite their work. So if you want to cite their work, you can go below and you can basically cite their work here. So you can find on my video also, I'll just cite their work. So they just describe each and every parameters and what's the current trend, how the data is following and so on and so forth. So these are the different things that they put on their websites. The test share of COVID tests that are positive. So that is the recent stats that is going on across different regions, different countries. Uh, Actually, my internet is little slow today, so I apologize for being this getting loaded. So you have different statistical graphs and you can draw various observations, and mind you, this is publicly available, so you can basically uh, get. And so they also mention different measures or actions that you want to make, like social distancing, wearing a mask, then maintaining some distance while communicating to people, and other health precautions that you need to take. So there are different things that is available. So for different countries and what is the current story that is going on across different globes, you have all this data. So this is a very good website for gaining different information regarding the recent pandemic that is going on and what the trend that would be there in the next couple of months. So you have like all the different things that you need to get for your analysis purpose and for other things as well. So if you want to do the citation of this is the uh, link that you would like to paste on your work. So I suggest you, like, if you are using or taking any work, although it is available freely, but they mention like they took this work from different peoples and organizations like World Health Organization and different hospitals across the globe. So obviously, the patient's data which they release, that would be of very confidential information. So, and different other characteristics that signify the patient will also be associated with it. So that's why you need to cite this wherever you use this particular data set or any part of this data. Okay, so they also have a GitHub link, so from where I have got this data set. So this is the GitHub link they have updated. So they updated very recently. So this is what they have updated today. So that is 5 hours ago. So they provide data sets in CSV format, text format, then JSON format, XLS format. So you can download in any of the format and you are free to do the data analysis purpose. So if you feel like you want to do any more activities or EDA activities on your data, or if you feel to build your linear regression models or any machine learning models, or if you want to do the clustering. So since I have guided you how you can do the clustering, if you have time, then I encourage you to take this data set, build a model, do all the pre-processing, and then you can basically get the insights how these things are done. And don't just do it for your sake, but also you can also put on your resume, so that whenever a recruiter asks or for any interviews, you can say you have used these many libraries, you have seen so and so for things. So this data set, they keeps on updating. So it's automatically updated every day. So whenever you are watching this video, make sure you take the recent data and do the EDA activity on that. Okay, so today is 17th of October 2020. So that's why I'm taking this data set. So I have a XLS data set. We have been working with CSV data set, so that's why I've taken a XLS data set. So this is my notebook. So I have my data set that is loaded here. Okay, so first I'll be basically using the Pandas library. So that is for data analysis purpose, summarization purpose, and for visualization I'll be using the matplotlib and also the cbond library hand in hand whenever as required. Okay, and there you can see there is one import warnings, and I have used the warnings dot filter warnings. So sometimes due to the incompatibility of your Excel file or the old version of your Jupyter notebook, or if you are working on collab, so what happens is some things might get deprecated, it can be old. So there at times you get to see some warnings. So we have seen these warnings when we built our linear regression model. So to ignore that warnings, or if you don't want to print them on the screen, it's not printed but it's automatically popped up. So if you want to ignore all of those things, just write this import warnings, and from warnings you invoke the filter warnings and pass a string that is ignore. So it will basically stop doing all those warnings which you get when you execute any statement. So those kind of things happen when you build a regression model. So if your data set consists of NA values, and your regression model then will pop this kind of warnings, like to drop these NA values or do some missing value treatment and so on. So for that you'll use the warnings and you ignore them. So currently I'm not doing a or building a linear regression model, just I want to understand how my data looks like and what is the current trend on the global pandemic is about. Okay, so I'll just run this. Okay, and this is how we read a Excel file, that is pd.read underscore Excel. So in the previous all videos we have used or we worked with CSV data. So just for a change, I have used the read underscore Excel. So the name of my data frame is COVID, and I'm just printing the COVID dataset. So the dataset looks something like this. It is a very massive data set which consists of 41 different columns. So this is how this looks like, and there are approximately around 50,000 records, that is entries. So it is such big data set that you have for this. Obviously it is of like many dataset, but they have trimmed this because each of the machine has its limitations and granularity for processing. So whenever you do any processing or activity, it would obviously take some time. Okay, so this is how a small glance of my dataset looks like. So you can see there are different NaN values, there are different columns, like you can take your time and go through all of these columns that are available. Currently there are 41 columns that are available in this particular data set, and there are 50,725 entries which are there depicted by rows in this. So if I want to look at the shape or the volume of this, it is of this much. So, and what all are the data types that are available in this? You can see that is ISO code, which is of object, continent, which is of object, location, which is again of date, which is of object, but this is not accepted. Whenever we want to do any processing, we have seen like we convert date object to date time. So we'll do that activity down the line when we progress through different operations. And there are total cases float 64, that's fine. Then the new cases smooth, total deaths, new deaths smooth. Then total cases per million, new cases per million, new cases smooth, total deaths per million, new deaths per million, new deaths smooth per million. This smooth is actually they have corrected these values, and they have did some pre-processing before sending on to this particular repository or OWID. And there are different parameters which you can see: population density, population mean age, and so on. Then different other factors that aggravates the COVID disease, or which increases the mortality rate of COVID. So that is like they consider age as 65 older, 70 older, than the extreme poverty. There are some regions in our world where the economy is very poor, and they are like suffering very poverty rate. So those factors have also considered this. Then if that patient has any previous medical records like cardiovascular death rate, those things have also considered. Diabetes prevalence, then smokers, female smokers and male smokers, especially in European countries where the temperature drops like to 9 degrees Celsius, or like even below that to negative degrees. People usually they smoke in order to maintain their body temperature. So for that they have this data. Then hand washing facilities, hospital beds per thousand. So this is very crucial thing in recent times, since the patients are in such a number that you fall short of beds at hospital. So this is also a matter of fact you need to consider when you do any data analysis purpose. So obviously, as per your requirement, whenever you do the hypothesis testing for your model, you will understand what are the key performance that contributes to our model. So now currently, since you have 41 columns, it's not necessary that they all will contribute, but to some extent, where this data set was originally released, they might have did some uh, analysis or hypothesis testing, we say, or like how we decide which variables contribute much to the data, or what makes much of the sense. So 41 columns is just a subset of, can consider from many other columns. So if you feel like you want to build any model or do clustering, and then you can reject some of the columns and then consider that for your model building or further processing. Okay, So these are the different columns. So I gave a small overview of what the different columns are, and I guess I have, okay, so these are the different columns that you get. Okay, so that is the same thing, that is the 41 different columns which you have. So now I want to look at the different locations that are available from this data set. So since this is a worldwide data set, global pandemic data set is available, I just want to know what all are the countries that are contributing, or from where that I'm getting this. So uh, there are some countries like Azerbaijan, World, Egypt, Estonia, San Marino, Tajikistan, Comoros, Lesotho, then Hong Kong, Solomon Islands, and so on. There are many other values also in between. You can see three dots in between. Okay. Then first we'll check if these columns does contain any null values or any NaN values. So for that we have COVID.isNA. So this is the method, and this will return true or false. So if in any of the columns, out of the 41 columns, if any of the columns have the NA values or null values, it will basically enable true. That means ISO code does contain NA values, continent contains NA values, then location, it does not contain any, like it's not from any anonymous locations or so on. So that's why you have false, and so on up till all the 41 columns which you have in your dataset. Then just for a summarization, what we do is we just sum, like we just want to know what is the count of these NA values. So for that we use, instead of any, we just append it to this is NA, that is dot sum. So these are the different summation values which you get out of this, and this is just the data set that we previously seen. So now if your intention is to build a machine learning model, or if you want to do any clustering activity, so first what you do is, uh, after identifying that there are these many NA values, you basically will drop the NA values. So out of this 50,000, maybe approximately 5,000 or 10,000 records will be dropped from that. But dropping this NA values, uh, or like before considering any justification why you drop that value, you need to have a justification like why you drop that. So uh, like if you build any machine learning model, either treat the NA value by replacing the average or minimum value or maximum value, or depending upon how you want to treat that. So that is a good practice instead of dropping. So currently I'm not building any model or not doing any clustering activity. I'm considering all the NaN values just for my understanding how the data is and how the trend is across the so forth timeline. Okay. So since I'm very much concerned about my country, that is India, so first I will look for the COVID cases which are there in India. So I using a instance, that is India case is equal to COVID. So inside this you have a sub condition. So that is nothing but the location. So location here, if you see, this is a data frame. So in that data frame, I am checking like whether that location is equal to India, and then I want a data frame in return. So that's why I write COVID data frame, COVID of data frame, and inside that I have the sub condition. So the thing which you see in highlighted, that is a sub condition, and the result of that will be a data frame that I'm storing it in a variable that is India case. And if I run this, okay, and if I look at the head, so these are the different COVID cases which are presently there in India. So this is the, since starting from where it has there. So you can see the date, that is 31st of December 2019, and head will show just the first 5 entries. So this is fourth one, that is 2020. So that is January, and so far you have many entries. And if I want to look at the tail of this data set, this is how it looks like. So since today it's the October 17th 2020, so this is the recent data that I have. So if you are watching this video tomorrow or some other day, make sure you take the recent data from this particular website and then you do the analysis, so that you are updated and you get to know like how the trend is going on. They also have the previous data, like 1 month back, 2 months back data. You can do a time series analysis on this data as well. So I encourage you to do that also as part of your activity. Okay, then since I have this data sets, now I'm interested in understanding some of the plots and what makes it sense to make some plot. So I'm using the Seaborn library and the matplotlib. So matplotlib is a library which is dependent on the Seaborn. So so first what activity I'll be doing is I want to understand the total cases which are there per day. So it's observed like in newspapers they release the information, but it's not accurate sometimes from the hospitals they don't release that much amount of data because of some regulatory measures or security reasons. So this particular snippet will give you the plot of what the cases per day are there in India. So for that, I'm using a method that is called as set from SNS Seaborn, and in Seaborn you have a library called as RC params. So in RC params, I'm writing a construct, or this has a dictionary. So it takes the figure size, and the size of my figure is 1510. So obviously when you take this data set, and since the volume is very large, and since it started from last year, that is December 2019, and now it's a month of October, that is the 10th month. So you have a large volume of data. So there will be many kind of different dates which are there inside this. So the date which you see after this plot would be very squeezed, so that won't be well spaced because of the volume of the data. If I just show this, and I'm plotting a line plot for this, so the date is fixed. So in each day there can be different number of cases that is observed. So my dependent and independent variable I have taken in that way. So x is my independent variable and y is my dependent variable. So based upon the date, the total cases per day keeps on changing, so it's not fixed. Okay, and the data frame that I'm passing is India case, which I have from above, and I'm doing a plt dot show, and this is how my plot basically looks like. So you can see the date, it is hardly visible, black thick line which you can see. So if you want to see this date, what probably you can do is you can change this figure size to 100 200, but I don't think that would suffice this, since we know it's across all the timelines since this pandemic has started, and this is the recent date that is up to date. So this is a graph which shows how the uh, infection rate or the disease rate is going on steadily increasing. So what inference you can make? So this graph is essentially an exponential graph that is polynomially increasing. Okay, so since at some point of time it has started, so this should be the 31st of December 2020 or 2019, and then across you can see that there was not much increase or sharp rise, but somewhere in between you can see a disconnected plot here in between. Maybe on that day the records or the entries they got, that was maybe like corrupted or into some activity, it has broke. So it's part of the data analyst that we need to identify why this portion is like disconnected, what happened in this time period, or where the data has gone. But if you look after this, uh, at some point of time it is steady, but then it takes a sharp increase. That is a very sharp increase in the number of infection, and the total cases is rising like anything. So it's very like so you can see the scale, that is all these things are not in like one two cases, these are in exponential, so this are in a logarithmic scale. So that's why I said it's a exponential growth, and it's like ever increasing. So this is a very bad situation. You can see like there is an exponential growth of this that is happening. Okay, so let's see in the so forth days or in the upcoming months how this trend will change. Okay, so now what I'm interested in, I'm making an analysis for the last 5 days. So since the df.tail contains the last 5 records, I will have the last 5 days. So last 5 days is like from today, the last 5 day, like till the 13th or the 12th of the October. So if I want to see that, just precise data, not too much of the data, you can see this is how it looks. So from the 13th of October 2020 till the 17th of October, the trend is like this. So this again is a line plot. You can see that is this is a uh, very decent line that you can see. So we are not doing any regression. This is not a regression line, but how the rate of increase is there. So in each day it is steadily increasing the total number of cases. Again, this scale is on logarithmic scale, that is exponential rise that is happening. So just mind you, the logarithm and the exponential scale both are the inverse of each other. Okay, so since now we have identified the total number of cases that is observed per day, we want to check whether our government is taking any measures, or what are the total number of tests that is conducted by each of this. So for this, I have the same thing, just on the y-axis, I am doing the total number of tests. So it is taking some time. Okay, so you can see this is the plot since this pandemic has started and up till date. It's not from the last 5 days. Okay, that is the total test per day since this pandemic has started. So you can see that is there are some disconnectivity that is observed in this plot, that is in this portion or in this portion. Maybe the data was not made available, or it was mishandled or corrupted due to some reasons. We have to investigate why this kind of behavior is there in this. So we have to inspect where this data has gone. And so what inference you can make from the total number of cases per day and the total tests per day, it can be like they are doing the test daily. So each and every day, since you get new cases, that is like each and every day on every hospital you get new cases that rise, they are doing the daily test, like the health workers, the doctors, nurses, they are putting their effort. Also the people, they are also following the safety and regulatory measures by working from home or staying at home. So you can make such inferences. That's why this trend is there like this. So this is also exponential. The test is also doing, or it's being done daily. So the total test which is done in last 5 days, you can do by this. So if you see this plot, or like the inference, what observations you make from this plot, that is more important. To write this line of code is not that a big activity, but to get the data, clean the data, and then do the analysis, that is very crucial. Okay, so since this does not contain much variation and everything is like increasing exponentially or linearly, uh, you don't have to put much effort in understanding this. So you can understand like what the current trend that is observed. So this again is in a logarithmic scale, that is a total number of tests. And from the 13th of October till 15th. There are some data ahead this due to I have this screen size. I've just truncated this. Okay, so it is increasing. Okay, next, where I currently is there, that is Germany. I'm looking for the corona cases here. So for that, I'm doing location is equal to Germany, and this is how what the current stats of Germany looks like from different states, from different regions. Okay, so this is just for analysis purpose, and you have similar columns. There are some NaN values. Obviously, in Germany, since I know there are very less cases as compared to India, so here the cases are controlled. And if I want to see Germany case dot tail, it will show the last 5 records from this data set. Okay, that was some error. So these are the total number of cases that is there. So uh, on October 13th, there was around uh, 32,000. It's 3,29,453 cases. Then on the very next day, it was 3,34,585. Then 3,41,223, 3,48,000, 3,56,000. So today, for today's data, I don't know at what time period they have released this, but can be probably in the midnight. So based upon this stats, it seems like the cases are increasing, but it's not that steadily increasing, but there is a increase or a unit increase in the total number of cases that are there. So for the last 5 days, this is for Germany, and for the last 5 days, that is D last 5 days, I am doing the plot. So again here the cases are increasing. If you see, look closely at this particular plot, you can see on the 13th of October till the time it reached before 14, there is a small slight dip in this plot if you closely observe this, but then again it is steadily increasing. So it's not like it's decreasing there, or there is a dip in the rate of the total cases. It's also increasing. So since here in Germany we have this Oktoberfest and many such events that is lined up, and also so people are out there, they're doing different activities, but also they are maintaining the regulatory practices here. Okay, so this data shows this kind of trend that is also increasing. And now what I want to do is I want to understand the cases of India, China and Japan. So it's a similar construct that I want as a COVID data frame, and inside that I'm passing the location India, China and Japan. So that is for IJC. If I just run this and if I plot this, you can see the plot how it shows the growth of cases across these three countries. So it will take some time for plotting. Okay, so on this side you can see a legend which is a very long legend. So if I go to the top, that is the date it started. So you can see the date it started, that is 31st of December 2019. Then again it like it shows, so this color indicates that there was a mild growth of increase for this disease, but then later the palette changes and the severity of this color increases, and so it is very dark. So even the color is also falling short for this because it's a very long time period for to plot this. So this is for August and this is for September, and this is, so you can see approximately it shows the result from the last month. So this is 13th of September and today it's a 17th of October. So approximately just a 4-day difference. It shows the data again. So this huge spike which you can see, that is for India, and for China and Japan, you can see like in China it's almost like it's very less as compared to India. So you can see that is a very small observation, or hardly you can make any changes in that. And also in Japan you may see that there is a flat observation or flat rise. No, but it's very less. You can see some part where this legend ends. You can see some kind of changes that is there, but that is hardly visible in Japan. But in India, uh, it's remarkably observed, very much highly. Okay, so understanding the cases of Germany and India. So I have the same cell, and I'll just compare these two plots, how it looks like. Okay, so this is how it looks like basically, and you can see the date where it started, that is the 9th of September 2020, and that is for 13th of uh, October. So when you do the comparison, you have to take something in common, that is the date which is there followed, that thing is common, and some entries in between these kind of dates are dropped, so that is internally handled. So here in this plot you can see this rainbow kind of bar plot. So this is called as a bar plot, which you see that this has the same syntax like scatter plot and box plot. So that shows the trend of distribution, how this kind of data you can interpret. So for certain kind of data, especially for pandemic data, or when you have a very large population of the data, uh, some graphs or which graphs you need to use, that you should have an idea. It's not like that everywhere you put the scatter plot, or things for which you don't understand you put a donut chart or something like that. But for the appropriate data you have to put the appropriate visualizations. Okay, so in comparison with Germany and in comparison with India, you don't see Germany at all in this particular plot, because everything is consumed in like India itself. So you can see this rainbow plot. So this corresponds to the rise that is observed. So still the data. So this thing you have to read in this way. So this, that is the extreme right. So from here, that is the old data, that is from the 9th, approximately the 10th of September, and then the severity that is increasing. So now recently they have not updated. So as I mentioned, some dates in between there are some discrepancies. For that they have omitted the data that is for 17th or after 13th of September. So that's why you can see that is a line that is not that visible, so it ends somewhere here. Okay, so now getting the latest data. So this is how you sort the information based upon the date you wish to get. So the last day cases, so here I am putting for the August 24th 2020. So from the date, that is the 24th of August 2020, what are the different statistics? The same data frame, but it is sorted based upon the date. So earlier we were sorting based upon the location, that is from different countries. Now here we can sort this according to the date. So some may sort according to the date, some may sort according to the location and on different parameters. So I've shown two ways how you can get this data frame and do the analysis. Okay, and this is sorting the data with respect to the total number of cases. So we have a method that is sort values, and this is how it looks like. So what this data frame basically says is that in United States there is a very high number of infection that is currently observed, followed by Brazil, and India is at the third position. And in the fourth position you have Russia, and so on and so forth. So this particular information is too high, but we will visually understand how we can see this. Okay, so this is the top 5 countries with the maximum cases. So top 5 countries you have USA, Brazil, India, Russia, and maybe this is from South Africa. Okay, we'll just plot this. So to better understand this statistics, I'll do a bar plot. So that is the same plot we'll do for this, and the maximum cases, that is 1 to 6, it will not have all the 6 because we set for 5, so it will run from 1 to 5. And the color that I'm putting is based upon the location. I want to color this bar plot. So this is how it looks like. And in the very first and foremost place you have the United States, then at the second position you have Brazil, India is at the third position, then comes Russia with very few cases, and in South Africa it's very few as compared to all the four. So again, India.head, and this is for linear regression. So since I'm not doing a model building activity, that we'll see in some other video, this was for the data analysis purpose. And since I've mentioned before, you have some kind of object associated with the date, you have to convert to date time. So this is how you convert that, converting that string to date time. So if I say covid.dtypes, okay, okay, this is on that particular data frame, that is India case. So I should write India case. So see, in India case, it's not on the entire COVID data set, or in the COVID data frame we have did that change. It's in respect to that particular country. So in the data frame which contained all the information and stats of India, so in that I've made the change, and you can see earlier it was object, now it's converted to date time. So you can do for columns if you have any other columns where it's object, and if you want to convert it, this is the fix that how to convert this. We have discussed all these things when we discussed about pandas. So this is just a brush up of what we need to do for our data analysis purpose, that is for EDA. And finally, I want to sort the data. So for sorting the data, you use something called as map method, and in map you have dt.datetime.toOrdinal. So ordinal comes from order. So the data or the date data which you have, that can be in ascending or descending order. So in order to sort that from increasing to decreasing or in some order, you basically write to ordinal and you just sort that. So this is how it basically looks like. So it has converted to some string internally. So here if you see, it is of 4 to 4. So the same thing, but before that it was to the date actually what we saw here. So it was in this format, that is human readable format, but here it has converted to some ordinal data. Now you can do any operations. So it's like with the date you can't do any much of the group by or ordering of the data, but when you convert to some ordinal value, it becomes easier for data manipulation. So we can do the ascending order, descending order, from left to right, right to left. Okay, then you can put some wild cards, ends with 4, ends with 2 4, things like that you can do with this. So for that purpose we convert from date time to ordinal. So these are some of the common operations that you should do when you get any kind of huge data sets. So before this we had a housing prices data set. So in that we did some kind of activity similar to this, but the number of columns in this data set is very high and also the number of records is too huge. So your activity on this particular data set is not limited, so there can be much more done. The thing what I have not done in this is the outlier removal. So you can do the outlier analysis, which data is not relevant. You can go ahead and do the clustering activity to understand what are the different clusters. You can study them, you can make some meaningful insights, and also you can do some linear regression, so to fit a model and to predict on this particular date what was the total number of cases, something like that, or you can do a polynomial regression or multivariate regression on this particular data set. So well, that was all regarding about this data analysis using pandas on the recent global pandemic data. So if you have any doubts or queries regarding this, please feel free to ask in the comment section. I'll be happy to answer that. And if you're watching this video for the very first time, I suggest you to subscribe. And if you like this video, please hit the like button and also share it to your friends who are new to pandas, or who are trying to learn the data science, or if they want to get into the data science field, or they are preparing for some interviews. Maybe this kind of things can help them. And also you should mention this thing on your CV, so that whenever some interviewer asks, you can say like, I've worked with this many libraries, this many data set, I've done this many things, and so on. So that increases your chance for getting uh, your like job. So at this time, since the pandemic is also going on, there is a shortfall or the crisis of getting jobs and people are getting laid off. It's your job to improve your performance and productivity. So by this small kind of videos from me and from other websites, you can basically do this activity. So I hope you enjoyed this video, and thank you for watching.